welcome back to today. We have the evolutionary scientist Victoria Hart with us to talk about the Big Bang Theory. No, not the TV show, folks. The phenomenon that supposedly created our universe as we know it. Welcome to the show, Dr. Hart. It's great to have you.
It's great to be here, Mr. Hutchinson.
So today we have some questions from our audience and I about the Big Bang Theory. First things first, what exactly is the Big Bang Theory?
The Big Bang is the leading explanation as to how the universe began. To put it simply, it says the universe started as a small singularity. It then inflated over the next 13.8 billion years into the cosmos we know today.
How do we know that this happened that long ago? Who or what determined that age?
Although we do not have machines that can see back in time, we can use mathematical formulas and models to essentially recreate the Big Bang. Using those methods, astronomers can see the echo of the universe's expansion through the cosmic microwave background, or the CMB.
What exactly is the cosmic microwave background?
The CMB is believed to be the leftover radiation from the time the universe began. It represents the heat left over from the Big Bang. Humans cannot see the CMB with the naked eye, but it is still everywhere in the universe, just like dark matter. It's invisible to humans because it is so cold. It's only 2.725 degrees above absolute zero. To put that in perspective, that's minus 459.67 degrees Fahrenheit and minus 273.15 degrees Celsius.
You mentioned something called dark matter earlier. What is that?
Dark matter makes up roughly 80% of the universe. It can be made of baryonic and non-baryonic matter.
What is baryonic or non-baryonic matter?
It's composed of protons, neutrons, and electrons, and other things that contain them, such as atomic nuclei, which are the nuclei of atoms.
Now back to dark matter. How do we know that Now back to dark matter. How do we know that this exists, or what scientific proof is there?
Keep in mind that scientists calculate the mass of large objects in space by studying their motion. In the 1970s, astronomers were examining spiral galaxies, expecting to see the material in the center moving faster than on the outer edges. Instead, they found that stars in both locations traveled at the same velocity. This indicated that galaxies contained more mass than could be seen. They named this mass dark matter, since it cannot be seen with the naked eye.
Changing subjects, one of our audience members requested that this question be asked. What is the Higgs boson particle?
In order to know what the Higgs boson is, we need to know where it comes from. The particle is supposed to fill in holes in our present understanding of the laws of nature. One of these major ingredients is the Standard Model.
Sorry to interrupt, but what is the Standard Model, just for our viewers back home?
The Standard Model gives the framework for our current understanding of the fundamental particles and forces of nature. It is also a hypothetical, ubiquitous quantum field that is supposed to be responsible for giving particles their masses. In simpler terms, this is an always present field that defies space and time in order to give particles their mass. This field is named the Higgs field. Due to wave-particle duality, all these fields must have a fundamental particle associated with them. The particle associated with the Higgs field is called the Higgs boson.
Unfortunately, that is all the time we have for today. Thank you for this wonderful insight into the world of the Big Bang Theory. Dr. Hart, we enjoyed having you here with us.
It was great to be here, Mr. Hutchinson.